let's go through a couple of these problems from page 1 and page 2 of your student file. And I'll let you read through most of this, but I want to highlight a couple things. So when discussing the relationship between two quantities, we typically denote one quantity as the input, sometimes referred to as the independent. So I'm going to highlight everything that we find as input in terms of yellow, and then the output or dependent quantity. In a table, the input is generally listed first. Okay, so the input would be listed on first, or sometimes it's along the top if we're going to do rows. And then the graph also shown over here on the right is using a rectangular coordinate system, also known as the Cartesian coordinate system. It contains both a horizontal axis and a vertical axis. On a graph, the input quantity is generally placed on the horizontal axis. So here's our input quantity. We know it's a horizontal axis. It's generally placed along the horizontal axis, and I'm going to highlight right here the horizontal axis. It's also its measurement, its name, its variable declaration in terms of its temperature and its units in degrees in Celsius. And so then it also says, well, the output quantity is generally on the vertical axis. So I'm going to do the vertical axis in blue, and so the output, it's also known as the dependent quantity. The output is also on the vertical axis, and I'm going to highlight this as, and also I'm going to highlight its variable declaration, just so we have some point of reference in terms of what we're talking about in terms of the input and the output. So we can now state, I'm going to do this in green because, instead of yellow, so I don't have a yellow marker up here, what quantity and units of measurement are labeled along the horizontal axis. Well, the quantity, so in other words, it's saying define your variable. So we can call this T equals the temperature in degrees centigrade. And then what is the practical significance of positive values of this quantity? Well, if this would be all these values over here, 0, 10, 5, 10, 15, 20, and so on. So this would be degrees above 0 centigrade. And then negative values would be degrees below 0 degrees Celsius. And what does 0 C are represented between? So in other words, what are the tick marks there? And those tick marks, we counted them out from 0 to 20, and we have some individual tick marks. So how do we go from 0 to 20? These are equally spaced, so 5, 10, 15, 20. So this must be 5 degrees Celsius indicates each tick mark. Now I'm going to go ahead and let you guys do the vertical axis. Remember, make sure you have a variable, a letter, and its defined variable, its defined letter, and then also whatever its units of measurement are. Okay, looking over your answers, be careful here. So A can represent the altitude, but it's not just a plain old altitude, but it's the altitude above the Earth's surface. Because if you look back, you'll see here that Earth's surface is at altitude 0, so that's right down here. And so it's the altitude is measured from the Earth's surface, and altitude is our output quantity, and so we know that it's measured from the surface there. And so we want to state the entire variable altitude above the Earth's surface, and it's in kilometers. And positive values would be altitude above the Earth's surface, negative values altitude below the Earth's surface, and each one of those tick marks is represented by 2.5 kilometers. So there's going to be some definitions and some parts of understanding that you can put on your big idea sheet from this particular student page. So a graph is a collection of what we call ordered points, written in the point of, again, input and output. And so input is first, output is the second thing, and I believe in this case, oops, we have this backwards. This actually is incorrect. We should actually have the I'm going to just write it up here, because if we look back, we know that our input is temperature and our output is the altitude. So we want T equals the temperature in degrees Celsius, and A equals the altitude above, or altitude above Earth's surface in kilometers. So that's what your ordered pair would look like, where again we have the input sitting right here and then our output is sitting right here. So where is the point 10, 50 located in the on the graph? So we can go back to our graph, and 10 is an input value, and we need 50 is our output value. So we have 10 and 50 is right here. Okay. Where does the point, what does the point 10, 50 represent? Well, we can kind of read off the graph what it represents, because this is temperature and then the altitude is 50, or we can read right here in terms of our ordered pair. So 10 is representing the temperature, 50 is representing the altitude. So guys, we're using green for the temperature. So at 10 degrees Celsius, and then my output is blue, the altitude is 50 kilometers above the surface, or above Earth's surface. Oops. So again, we have an input and we have our output. Looking at question 6, I just want to point out here that points that lie on either the horizontal or the vertical axes are not in the quadrants. So the quadrants, you'll see back at page 1, 2, 3, 4. So this point E, J, L, and this point G do not lie in any of the quadrants. They either lie on the horizontal or vertical axes. And then that you can fill in part A and B there. And these are also known as the vertical intercept. So on the vertical axis, the input is always 0. So our input value is always 0. And it comes in the form 0, comma, B, where B is the output value when the input is 0. So the input will be 0, and our output is going to be B. Another way sometimes that I like to refer to this is just 0, comma, something, because it's some number that goes in the output value. Likewise, so if I highlight the 0 there and the B there, the horizontal intercept is the coordinate point where the graph crosses the horizontal axis. The vertical is where it crosses the vertical axis. So on the horizontal axis, the output value is always 0. And so the horizontal intercept is also, it's some values that ends in 0. The output value is 0, where the input value is, and we'll call it A this time. And so A is the input, where B, or the output, is 0. And so sometimes I will also write just something, some input value, comma, 0. And so that's another way to write that ordered pair that you're looking at. Last thing I want to mention is when we're graphing, again, you will identify your input and output. And your input is going to go along the horizontal axis. Your output goes along the vertical axis. But when we are graphing, and notice these values are going from 58 to 68 and 110 to 144, well, we know that this point right here is always 0, 0. It's always the origin. That never changes. But how we count this axis, or how we scale this axis, is can be whatever we choose it to be. And so when you guys fill in your notes and draft this, and you're going to put this as a discussion question, we want to make sure that the data points should be spread out across the grid, so both horizontally and vertically. And so it's important that it doesn't make sense to start counting from 0, 0. So you will want to put what we call a skew in our graph or a break in our graph, and we can do that by just putting 2 little slashes, and then you start with whatever number you want to. The next number will be whatever you're counting by. Sometimes you will break up just the horizontal axes. Sometimes you need to break up both the horizontal and vertical axes. But the idea here is not to have a whole bunch of points just bunched up here. You want to be able to spread them out across the graph.